Welcome back. Our topic tonight is inverse trig functions with derivatives and integrals. So I'll try to break them down, each one separately. We'll spend a couple examples on derivatives, a couple on integrals, and hopefully we'll be in a good place. So let's get into it. Alright, so here we go. Find the derivative of 1/4 tan inverse of x over 4. So probably the thing I would start with first is just recalling what the derivative is of inverse tan or arctan. Remember those are synonymous. So I would say that is du over the square, not square root, du over 1 plus u squared. So the derivatives are pretty nice. Basically, you just need to identify that u and du. So it's not a u sub, so to speak, because we're not integrating. We just need to pick a u and a du. So I would say my u, of course, is the junk in the parentheses, and I'm going to rewrite that as 1/4 x. X over 4 is 1/4 x. And therefore its derivative is just 1/4. So as I go to evaluate this, I'm going to say my derivative is whatever my du is, which I just said is 1/4, divided by 1 plus whatever I said my u is, squared. So 1/4 x squared. Now the other thing I want to note is that I did have a 1/4 in front of this, so I want to bring down my 1/4 as well, times this quantity. And now it's just the cleanup part, so this is where you just need to slow down and take your time. I'm going to say this is 1/4 over 1 plus. If I square everything I see inside here, that looks like 1/16 x squared. And again, we just need to clean this bear up. Probably the easiest thing to say, if you're quick enough, you can see that these 1/4s here are going to cancel. If you didn't see that, you could clean up inside your parentheses. I could multiply every term by 16, the common denominator. So I'd get 4 plus 16, 4 divided by 16 plus x squared. And then I could kill those 4s that way. So either way, it looks like I'm getting 1 over 16 plus x squared for my final answer. So let me go ahead and give you a similar one. Find the derivative of sine inverse of 1 over x. So again, we'll just, same setup here, you just got to know the derivative formula. So sine inverse, hopefully you're thinking du over now the square root of 1 minus u squared. So inverse tan was du over just 1 plus u squared. This changes from a plus to a minus and has a square root. So again, I would just identify my u and my du. My u is, junk in parentheses, 1 over x. Perhaps you want to rewrite that as x to the negative 1 when you derive it. So I get negative 1 over x squared as my derivative. So go ahead, and this cleanup is a little goofier, so I guess I'll run through it with you. I'm going to put negative 1 over x squared divided by the square root of 1 minus my 1 over x squared. Now, you might be thinking that's pretty straightforward, and if it was a free response question, sure, that would be full credit because we don't have to clean up. But on the multiple choice, we do have to kind of match their answer. So the first thing I'm going to do is, would you agree I could multiply both of these by x squared, and that would reduce this here. So I'm going to say I get negative 1 over x squared of this junk, and I'm going to square that, so I'm going to say 1 minus 1 over x squared. Alright, now again, I'm just going to clean up underneath the radical. So I've got negative 1 over x squared. I'm just cleaning up inside the radical. I'm saying that 1 is truly x squared over x squared. So I get x squared minus 1 over x squared. So hopefully nothing too mind-blowing there. And now I basically have one step left. Ask yourself, when you have a square root, can you take the square root of x squared? And hopefully your answer is, of course, that answer is just x. But can you take the square root of x squared minus 1? Well, that answer, of course, is no, because there's a plus or minus. So I'm just going to rewrite this in a few steps, so hopefully it becomes obvious to you. When I square root a fraction, I'm really square rooting the top, and I'm also square rooting the bottom. Alright, just like if you were squaring a fraction, you square the top and you square the bottom. If you square root it, you're doing it to the top and bottom. Now, I really can't do anything to this top because of the plus minus sign, but I do know that this turns into just a plain old x. And notice that it is on the bottom, so that's going to cancel with one of these x's. So I'm going to get a final answer of negative 1 x square root x squared minus 1. Okay, so if at any point I talk too fast to you, that's a pretty common algebra step. I mean, I tried to say it as slow as I could. Pause it, rewind it, go back and try it again. Alright, so let's practice, like I said, a very, very similar one. Find the derivative of arc sine of 8 over x. So you're on your own, pause it, see what you get. Alright, so I've got my work off to the side here. I have identified my u as 8 over x. So I rewrote it as 8x to the negative 1. Its derivative is negative 8 over x squared. And here's my rule. So I'm simply writing my du over my square root of 1 minus u squared. And that's this substitution. You'll see that I then quickly move the x squared to the bottom. I just multiplied the top and bottom by x squared. And I squared this fraction in here. If I keep going, you'll see that I then got a common denominator. So this is x squared over x squared. So x squared minus 64 over x squared. And again, I'm just separating my radicals. And this bottom radical turned into an x, which canceled with one of those. And there you have it, final answer. Now, the arc trig integrals are a little more exciting. So let me recall what you're supposed to get these to look like. You want the integral of du over the square root of a squared minus u squared. Notice I'm not using 1. A squared minus u squared. And this is equivalent to arc sine of u over a plus c. And the other bear I'm looking for is du over 1 plus u squared. And this is equivalent to 1 over a arctan of u over a plus c. Okay, so again, these should look like the derivatives inside here. If you ignore these integrals, this should look like the derivative for arc sine and the derivative for arctan. Oh, shucks. I didn't mean 1 here. I meant a squared plus u squared. Sorry about that. It should be a squared plus u squared. And again, this should look like the derivative for arctan. Now, likewise on this side, they're both u over a, and the arctan has that extra 1 over a. So we'll go through a couple slowly, and hopefully we'll be able to recall what we did earlier in the year. Alright, so evaluate the integral of x over the square root of 1 minus x to the 4th. So here's typically how I start, talking this through to myself. Again, I never think arc trig first. This is the last thing that comes to my mind. I'm trying u sub to begin with, and I'm going to do a u sub in my head. If I pick the, what's inside the radical as my u, 1 minus x to the 4th, I know its derivative is 3x to the 3rd, which isn't going to cancel with a plain old x. So I know u sub isn't going to work, and now I think, okay, maybe it's one of those sneaky arc trig integrals, and usually there'll be a multiple choice, and that'll kind of trigger my thought. So the first thing I say is this, arc sine or arc cosine. The radical hopefully gives it away as arc sine. So I jot down on my paper my du over the square root of a squared minus u squared. My goal is to get that integral to look like this integral. Alright, so basically I start with my a and my u. Now remember, a has to be something that when you squared, you get 1, and your u has to be something when you square it, you get x to the 4th. So I would say my a equals 1, obviously because 1 squared is 1, and my u is actually x squared, because when I square x squared, I get x to the 4th. Okay, so my a is 1, my u is x squared. Now because I'm integrating, unlike deriving that we just did, because I'm integrating, I actually still need to do a u sub. So if my u is x squared, my du then is 2x dx, and I get du over 2x. Alright, so unlike what we just did, we need u substitution on this point. Alright, so I'm going to keep chugging here. And I'm going to get the integral, I'm just rewriting it, of x over. I now have my a squared minus u squared. And in place of the dx up here, I'm going to put in my du over 2x. So my x's should cancel, and I can pull out a 1/2 integral du over the square root of a squared minus u squared. Now once I've officially matched it up to, its integral, or my original integral, I can just simply write down my answer. So the integral of arc sine is just arc sine of u over a. My u was x squared over my a was 1 plus c because I have no bounds. The only thing I'm going to multiply by is this 1/2 because it was in front of my integral. And there you have it. So we'll try a few more if you were a little shaky or forgot about these. We'll try a few more. Here we go. Alright, so this time I'm saying the integral of dx over 4 plus x squared looks like, try u sub. U is 4 plus x squared. The derivative is 2x. Clearly the x won't cancel. So I need an a and I need a u. Okay, so remember, it's who u squared to get this answer. So I would say my a is 2, and my u is just a plain old x. Alright, therefore I need a u substitution. If my u is x, my du then is just equal to 1 dx. And I'll just recall that this integral is du over a squared plus u squared. So here we go. I'm going to get the integral of... I can put my du in here, square root of, what am I doing? Whoa, jinx that. Du over a squared plus u squared. So this is a pretty straightforward one. Nothing canceled with my du. So I end up with 1 over a arctan u over a plus c. And there you have it. So we just have to remember that it's that 1 over a for arctan, and of course you could rewrite arctan as tan inverse. Again, they are the same thing. Alright, evaluate the integral of e to the x over 1 plus e to the 2x. So again, if I just do a general u sum, 1 plus e to the 2x, my derivative is e to the 2x times 2, which clearly would not cancel with an e to the x that I have up on top. So again, I'm thinking arc trig. Obviously arctan in this case. So pause it, try it on your own, come up with your a, your u, and see what you get. Pause it, see what you get. So I thought before I went any further, I'd just show you what I've done. I said I need 2 terms squared. 1 squared is 1, so my a is 1. E to the x squared is e to the 2x. Obviously multiply exponents, so my u is e to the x. If my u is e to the x, my du is e to the x dx, which is du over e to the x. So when I substitute that in, I've got e to the x over, obviously I should have had a dx on that, 1 plus e to the 2x dx. I'm really getting e to the x over a squared plus u squared times du over e to the x. So those cancel. And if I keep chugging here, I get the integral, obviously, of du over a squared plus u squared, which is my 1 over a, which is just 1, arctan of u over a plus c. Alright, well, it's that time. I'll be looking for this one in your notebook tomorrow, so make sure you get her done. We've got a nice integral, dx over the square root of 9 minus 4x squared. See what you get, and we'll see you tomorrow. Have a great night.